A says, suppose a point A is 6 feet above the ground, and that at time 0, the ball is at point A. Suppose the length of OB, this whole distance here, is 88 feet. Include this information in the diagram. So once you've sketched or added those numbers to your picture, you can check off that you've finished part A. Part B says, suppose that after 1 second, the ball is at its highest point of 22 feet and has traveled a horizontal distance of 44 feet. What are the approximate coordinates of the ball at the following values of t? I'm going to write mine in the form of a table to help me organize my thoughts. So I have 0 seconds, a quarter, half, 3/4, 1, 1 1/4, 1 1/2, 1 3/4, and 2. From the sentence in part B, it says that at 1 second, the ball is at its highest, which is 22 feet, and has traveled a horizontal distance of 44 feet. We know at time 0 from part A that it is no horizontal distance, but it is 6 feet high. And we know also from A that it has traveled 88 feet horizontally, and it has landed on the ground, so it's a 0 for its height. Now we're going to split this 44 in half, so that way we can fill in that piece of information. 44 divided by 2 is 22, and then we can split it in half again to figure out these pieces. So 0, 11, 22, 33, 44, 55, 66, 77. And now we're going to look at where it would be at a quarter of a second. So if it was like 11 here, how tall is that? And so we know that it was originally 6, so we could say that at 11 it might be 8, 9, or 10 feet high. This is an approximation. Then at a half of a second, it looks like we're a lot closer to 22 now, so maybe around 18 or 19. And then at 33 seconds, we're even closer. And then at 55 seconds, we're starting to fall back down, maybe around 19. At 66 seconds, looks like we're a little bit over 10 maybe. And then at 77 seconds, it looks like we're below 6. So maybe, oops, I did mess that up a little bit. Maybe 5. And remember, these are all approximations. So if yours looks a little bit different than mine because you predicted different heights, that's okay. But you definitely want to make sure that your X values match up with mine. Your Y values might be slightly off just because it's an approximation. Now I'm going to clean this up so we can talk about C and D. In part C, it's asking us to make 2 predictions based on our graph. And so we could say that at 1 second, the ball has traveled 44 feet and is 22 feet high. And that's going to count as one prediction. Then we're going to make another prediction. We could say at half a second, the ball has traveled 22 feet and is approximately 18 feet high. And that's based on our table or our points from part B. We're using our information from the previous problem to help us come up with some predictions or some sentences describing what we came up with. Part D says, what's happening to the ball when its coordinates are 88, 0? So right here at this point B, why is that at 88, 0? What's happening? The ball has landed on the ground. 88 feet from where it started. Part E says, why do you think the ball is at 0.06 when it starts? In other words, why isn't the height of the ball 0? When you throw a ball, does the ball start on the ground? The reason it is 6 feet from the ground is because someone threw it. F says, does a graph allow us to make predictions about the height of the ball at all points? And we can make predictions? That are estimates, but we cannot predict exact values, at least not yet.